We're solving problem 5 from the 2021 Fall Amc 12B test. Call a fraction a over b, not necessarily in the simplest form, special if a and b are positive integers whose sum is 15. How many distinct integers can be written as the two, not necessarily different, special fractions? So, first we can say that a is equal to 15 minus b, since we know that the sum of the two integers a and b is 15. And we can divide both sides by b to get a over b is 15 over b minus 1. This 15 over b is what we really want to focus on because, well, this minus 1, we don't have to incorporate it into the number of numbers. So for 15 over b, if we want this whole dividend to be an integer, we have 15 over 1, 15 over 3, 15 over 5. This yields just 15, 5, and 3. So, we want to find all the possible numbers that can be summed here. Let's start with 15. 15 plus 15 is 30. 15 plus 5 is 20. 15 plus 3 is 18. And then now we've exhausted all the 15s. Let's go to 5. 5 plus 15 is 20. We already said that. 5 plus 3 is 8. And that's the only possible. And then we have 3 plus 15, 18, already said. 3 plus 5, already said. We overcounted 5 plus 5, which is 10. And then there's 3 plus 3, which is 9. And for the 3, we can't add it to any other value because we already have exhausted all the other possible choices. Well, what else can we do? If we split this into half, we have 15 over 2, 15 over 6, and 15 over 10. This simply yields in, I'll do fractions, 7 and 1/2, 2 and 1/2, and 1 and 1/2. We can then sum these numbers, and you can just do the same thing in this case, where you just keep on summing until you can't anymore. You get 15, I'll just write it out, 10, 9, 5, 4, and 3. Now, we can then split this in half again, the denominators, into quarters, where we only have 15 divided by 4 and 15 divided by 3. This yields 3 and 3/4 and 1 and 1/4. So the only number is these two summed, so 5. Now let's see here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But notice, we have 1, 2 5s, and we have 1, 2 10s. That means we have to subtract a total of 2 numbers from the total of number of numbers, which is 13, as there's another set of duplicates. So 13 minus 2 is 11, our desired answer for this problem.